Alright, so now we are in chapter 4.3, which is property of logarithms. Our objectives. And let's start. So the first property we're going to learn is the product rule. So let B, M, and N be positive real numbers, where B is not equal to 1. And we have the following property. So you have the log base B of M times N. So inside your argument, you have a product. You have a product inside your argument. So the rule is, or the property is, that you take it from one log into two logs, and they have to have the same base. So now you have log base B of M plus log base B of N. So the product goes into two logs, and now you are adding. The second property is where you have a quotient in your argument. So again, B, M, and N are positive real numbers, and B is not equal to 1. And this time we have log base B. Again, our base is B. And inside of our argument, we have a quotient. So they're each going to get their own individual logs with the same base. And it's going to be log base B of M minus log base B of N. So you go from a quotient to now a subtraction. Let me go back one. So if you have a product in your argument, you're going to end up with separate logs, and they're going to be adding in between them. And if you have a quotient inside your argument, they're each going to have their separate logs, but you're going to be subtracting. Okay. Third property is called the power rule. So we have log base B of M raised to the P power, where P is the exponent. And the property is that the exponent becomes the coefficient, which is just a number on the outside of the log. So your exponent becomes your coefficient. The log base B of M stays the same, just the exponent is now written in front of the log, so he is the coefficient. Alright, let's go in our books to page 477. We're going to start by looking at problem number 1. And it says, use the property of logarithms to expand each log expression as much as possible. Where possible, evaluate log expressions without using a calculator. So it says log base 5 of 7 times 3. Log base 5 of 7 times 3. Well, we see we have a product in our argument. So the rule is that we're going to separate it. So we're going to have two individual logs, so log base 5 of 7 plus, because you add in between, log base 5 of 3. We had two things being multiplied inside our argument, therefore we should have two individual logs. So we have log base 5 of 7 plus log base 5 of 3. And of course we cannot evaluate these without a calculator, so we leave it in that form. Alright, let's look at number 11. So now we have log base 4 of 64 divided by y. So we see we have a quotient in our argument, so we need to separate. So we're going to have two logs. So now we have log base 4, make sure your base stays the same, of 64 minus log base 4 of y. Okay. Now our first log, log base 4 of 64, we can simplify that, and that would be written as log base 4 of 4 raised to the third power. Because remember, 4 to the third power is the same as saying 64. When your base and your argument are the same, and in essence, remember, it cancels out and you're left with just that exponent, which was 3. So really the answer is 3 minus log base 4 of y. Don't forget to simplify the problem if you can. All right, number 23. So this time we have log base 4 of the square root of x divided by 64. And of course we have a quotient, so we're going to go ahead and separate this to two logs. So now we have log base 4 of the square root of x minus log base 4 of 64. Okay. So the square root, we need to write that as a power. So recall that the square root of x is the same as saying x raised to the half power. So this is log base 4 of x raised to the half power minus log base 4, and the 64 we can rewrite as 4 to the third power. Okay. Now we just had a property that when we have an exponent, the exponent goes away, and all we do is move it in front of the log, so it becomes the coefficient. So this is a half log base 4 of x minus, well, our base and our argument are the same, so these cancel, and we're left with just this exponent, which is 3. All right, number 31. Number 31, we have log of the cube root of x divided by y. The cube root of x divided by y. Okay, so before we can even use the property where we have a quotient, we have to get rid of this cube root, or we can rewrite it. So let's recall that we can rewrite the cube root as the log of x divided by y, all raised to the 1/3 power. Then from there, before we can even still use the properties of the quotient, we have to take care of this 1/3 power. So the 1/3, the exponent, is moved in front of the log, so it becomes the coefficient. So we have 1/3 log of x divided by y. Okay, so now we have the quotient of x divided by y is not raised to a power that's in our way. So we have 1/3. Now we're going to go from one log to two logs, so we have two things dividing. So we have log of x minus the log of y. But remember that this 1/3 is on the outside of this entire thing, so use brackets or parentheses. So this is 1/3, and then quantity, log of x minus log of y, or you can write your answer as 1/3 log of x minus 1/3 log of y. All right, last one, number 37. 37 says the natural log of x to the third power times the square root of x squared plus 1, all divided by x plus 1 raised to the fourth power. Okay, so first thing first, we need to go ahead and rewrite the square root. So that's still the natural log, and this time we have x to the third power times x squared plus 1, all raised to the half power. Because remember, the square root is like saying the half, and all of this is being raised to the half. Divided by x plus 1 raised to the fourth power. Okay, so now we want to expand this. So we notice that we have a product on the top, but there's also a quotient. So this is how the rule really works. If your arguments are multiplying, then you're adding their logs. If you have an argument that is dividing, then you are subtracting its log. So this will become the natural log of x to the third power plus the natural log of x squared plus 1 to the half power, because remember these two are multiplying, so they should be adding in between them, and then minus the natural log of x plus 1 raised to the fourth power. The x plus 1 to the fourth power is in the denominator, so he's dividing, so you should be subtracting his log. Now the last thing we need to do is go ahead and put these exponents as coefficients. So the exponents become coefficients. So this is 3 times the natural log of x plus a half times the natural log of x squared plus 1 minus 4 times the natural log of x plus 1. Now you know you're done when, if you look inside each argument, so this one says x, this one says x squared plus 1, and this one says x plus 1, and you do not see a product or quotient, and also each of these exponents are those invisible ones. So this is x to the first power, there's a 1 up here and a 1 up there. Therefore, this is your final answer. All right, let's keep going. All right, so now we want to condense log expressions. So they're given to us in an expanded form, and this time we must work backwards and condense them. So our same rules apply, except for they're written backwards. So we have log base b of m plus log base b of n. Well, we have two separate logs. They have the same base, and they are adding in between them. Therefore, what we're going to do is condense it down to be one single log, and each argument are going to be multiplied together. So this becomes log base b of m times n. Same with log base b of m minus log base b of n. You condense it down to one single log, same base, and since we are subtracting, we're going to divide the argument. So m divided by n. Okay, so remember what's in front of this log is a positive sign, right? So if it's a plus sign in front of the log, its argument is going to go on the top. And if it's subtracting, its argument is going to go on the bottom. And then the last one says, well, you can make the coefficient now the exponent. So that p will become an exponent, and you'll end up with log base b of m raised to the p power. All right, let's go back to our books, page 477. We're going to start by looking at number 41. And it says, use the properties of logs to condense each log expression. Write the expression as a single log whose coefficient is 1. Where possible, evaluate log expressions without a calculator. So it says the log of 5 plus the log of 2. I'm sorry, I wrote that wrong, didn't I? Log of 5 plus the log of 2. Okay, so we have two logs. They're adding. The coefficients in front are 1, so we know we're able to do our property. So we're going to go to one single log. So now we have log. The base has to stay the same, which should be base 10, right? And then we're going to take each argument and multiply them together. So it's log base 10 of 5 times 2, which is the same as saying log base 10 of 10, which simplifies down to just be 1. Don't forget to simplify if you can. Okay, number 49. We have the log of x plus 3 times the log of y. And again, we need to condense. So when you're condensing, before you can do the properties that we learned, let me go back. Before you can do properties 1 and 2, the coefficient in front of each log has to be a 1. Okay, so this has a coefficient of 1. However, this has a coefficient of 3. So the first thing you want to do is make the coefficient the exponent. So this becomes log of x plus log of y, now to the third power. Now the coefficients in front of each log are 1. So we're going to go ahead and condense them to a single log. So it's going to become log. And of course you can write base 10 because we know it's base 10. And since they're adding in the middle, we're going to multiply. So it's going to be x times y to the third power. All right, number 61. So we have 3 times the natural log of x plus 5 times the natural log of y minus 6 times the natural log of z. So again, we want to do our properties on the previous slide, but again, we have coefficients that are coefficients that are other numbers besides 1. So you need to take each coefficient and make it the exponent. So the 3 will become the exponent, the 5 will become the exponent, and the 6 will become the exponent. So this becomes the natural log of x to the 3rd power plus the natural log of y to the 5th power minus the natural log of z to the 6th power. Now we have 3 different logs, and we want to condense to one natural log, so this becomes just a natural log. Now, watch this. What's in front of this natural log? Well, it's a positive 1, right? Which means in my argument, he needs to be in the numerator. So that's x to the 3rd. What's before this log? Well, a plus sign, which means he's also in the numerator. He's being multiplied. And what's in front of this log? A minus sign, so he's in the denominator. And that's condensed. Last one, number 67. And it says 1/3 times 2 the natural log of x plus 5 minus the natural log of x minus the natural log of x squared minus 4. Okay, so first thing first, what I'm going to do is work on the inside of these brackets. So each one of these logs needs to have a coefficient that's 1. So this 2 is going to become the exponent for this entire argument, and the rest of them have coefficients that are 1, so it's good. So this will become 1/3. Now we have the natural log of x plus 5 squared minus the natural log of x minus the natural log of x squared minus 4. Okay, so that 1/3 still on the outside. We haven't done anything to him yet. Now we have just a single natural log, and what we're going to do is combine our arguments, right? Well, in front of this natural log is that positive sign, so that's x. I should use brackets 1 second. That's 1/3. And then we're going to have the natural log, the single natural log. And it's going to have x plus 5 squared, because he's positive. This entire argument is going to be in our numerator. Now this says minus the natural log of x. Because it's a minus sign, the x is going to be in the denominator. And the same here, minus sign. So the x squared minus 4 will be inside our denominator as well. It's getting a little messy with brackets everywhere, isn't it? Okay, so we're almost there. So we have a single natural log. So really we have 1/3 times the natural log of x plus 5 squared over x times x minus 4. The last thing we need to do is move this 1/3. We need our coefficient to be a positive 1. So this 1/3 is going to become the coefficient, but realize that it's on the outside of this entire argument. So this will become the natural log of x plus 5 whole thing squared over x times x minus 4, all raised to the 1/3 power. This entire thing is raised to the 1/3 power, since the 1/3 was on the outside of the natural log, and this is the entire argument. All right, one more property to go over, the change of base property. So we know our calculators will do log base 10 and the natural log. But what if I had log base 3 or log base 8? What you could do is do a change of base, so then you could use your calculator. So it says for any log bases a and b, so any numbers a and b, and any positive number m, if I had the log base b of m, my change of base formula would be the log base a of m divided by the log base a of b. So how I write this could be written as log base 10 of m divided by log base 10 of b. So you're going to first you put your argument, so you got log base 10 of your argument, and then you get log base 10 of the base, and that's your change of base formula. Also, since your calculator does base 10, it also does the natural log. So the natural log of m divided by the natural log of b, where again m is the argument and b is the base. Doing either one of these quotients will come out to be the same answer. And this is what I just wrote on the previous page. So this is log of m divided by log of b. Well, remember, since it's invisible, it's base 10, and it's the argument, and then it's the base. And now it's the original base. And the same here, the natural log of m divided by the natural log of b. I usually use this one always, because they'll give us the same answers. Alright, let's go in our books to page 477 still. We got 3 more problems to look at. So let's start with number 71. So number 71 says use common logs or natural log and a calculator to evaluate to 4 decimal places. So 71 has log base 5 of 13. Well, our calculator does not work in base 5, so I'm going to use the natural log. So this is going to become the natural log of 13 divided by the natural log of 5. You see, it's automatically the natural log of the argument divided by the natural log of the original base. And use your handy dandy calculators. So 1 second. Now when you're typing in these calculators, be sure that you are doing natural log, and then open up a parentheses, right? Type in 13, close your parentheses, then do divide natural log, it'll open up another parentheses. And you should get approximately 1.5937, round to 4 decimal places. Alright, let's look at number 77. So now it has log base pi of 63. Well, pi, it could be a base. Well, unfortunately, your calculator doesn't work in base pi, so what we're going to do is do a change of base. And again, I'm just going to use my natural log. So I have the natural log of 63 divided by the natural log of pi. And again, let's use our calculators and let's see what we come up with. And I have 3.6193. Great. Last one we're going to look at is number 79. It says use a graphing utility and the change of base property to graph each function. So remember before, in order to graph log functions, you had to graph the exponential form, then switch the x and y, and that will give you the log form. So now they're telling us we can use the change of base formula and our graphing calculators instead. So we have y is equal to log base 3 of x. And we want to graph this, but unfortunately your calculator does not work in base 3. So let's rewrite this. This will become the natural log of x divided by the natural log of 3, right? Which means in your calculator, at the top you should see y equals. Go ahead and hit y equals. If you have anything in y1, go ahead and clear it, and we're going to input this function. So you should hit the natural log and open up a parentheses, type x, close your parentheses, then do divide by the natural log of 3. And then you can hit graph. And change my windows. Hold on. Good. You hit graph, and you should end up with the following sketch. Doesn't look exactly like this, but it should look something like this. Let me erase it and try a little better. There we go. Okay, so this will conclude our video for 4.3. Please email me if you have questions.